ABC is an equilateral triangle. D lies on BC. AD is perpendicular to BC. We need to prove that triangle ADC is congruent to triangle ADB. So remember, there are 4 different ways of proving congruency. Remember, congruency means that the triangles are identical to each other. We could prove it by saying that all the sides are the same, so SSS. We could do it by proving that the 2 sides and the angle between them are the same, or 2 angles and the side in between those are the same. Or if we have a right angle, then we can do it just by proving that the hypotenuse and one of the other sides is the same. In this case here, we have a right angle. We know that's a right angle there. We know that has to be a right angle there because we know that BC is a straight line because this forms one of the sides of the triangle. So we've got a right angle in both of the triangles. So actually this final one is probably the easiest to do. So let's mark on some information onto here to help me. ABC is an equilateral triangle, so I know that AB is equal to AC, which is also going to be equal to BC. All 3 sides are the same in an equilateral triangle. So the first thing I'm going to write down is AB equals AC because it is an equilateral triangle. Okay, so I've proved that the hypotenuse is the same in both of these right angle triangles. I'll also say that ADC equals ADB equals 90 degrees, just to prove that there's the right angle in both of them there. And the only other thing, so I've done the right angle part, I've done the hypotenuse part, now I just need to say there's a side that's the same in both of them. Well, side AD is common. And what I mean by that is it is in both triangles. The side AD is in triangle ADC and it's in triangle ADB. And because it's common, it has to be the same. So therefore, I've proved that there's a right angle in both triangles. I've proved that there's a hypotenuse that's equal in both triangles. And I've proved that there's a side that's the same in both triangles. So right angle hypotenuse side. So therefore, ADC is congruent to ADB by RHS. So that's part A done. Part B, hence, so we want to use what we just did to prove that BD, this length here, BD, is half of AB. So I want to prove that this is half of this. Hence means use what you just did. So I've just proved that ADC is exactly the same as ADB. So given that fact, so given ADC is congruent to ADB, so they are identical, that means that BD, this side here, I'll mark that with 3 little lines, the side BD is identical, is equal to the side BDC. If this triangle is identical to this triangle, then those 2 lengths there are identical. So BD equals DC. Or another way of saying that is if these 2 are the same, then D is in the middle of BC. Or I could say that BD is also equal to half of the whole thing. This is half of BC. Now, I also know that BC is equal in length to AB, because remember it was an equilateral triangle. This is equal in length to AB. So BC also equals AB because it is an equilateral triangle. Therefore, combining these two results together, I've got BD is equal to half BC, and we know that BC is the same thing as AB. There we go, we've proved that result.